A very welcome I speak to all audience and viewers. Today, me and my group members, Bhupinder, Ikhwan, Eiriel and Adam are going to conduct an experiment on kitchen metallurgy. In this video, you will learn about annealing, quenching and tempering process. For your information, we are conducting this experiment at home due to the COVID-19 pandemic in Malaysia. Now, let's start.
Okay, we start with the procedure. Firstly, we start our experiment by preparing materials such as paper clips, bobby pins, pliers and water. Next, set aside one bobby pin and one paper clip for comparison. They are used as control. After that, we come to annealing process. Heat the loop of one bobby pin and a loop of one paper clip red hot and slowly lift out of the flame. Slow cool. When heating the bobby pin, it is advised to use pliers or tongs to grip the open end of the pin so that it separates the two sides of the pin. This allows the pin to heat much faster. Then, continue with quenching process. Heat 2 of each until red hot and quench in ice water. Quick cool. Finally, it is tempering process. Take one of each from step 3 and heat again in the top of the flame for a few seconds and then quench. Do not let it get red hot.
Here is the table of results for our experiment.
I'm going to explain the theory about annealing process. Annealing is a heat treatment process used to increase the ductility and reduce the hardness of a material. After annealing, the dislocation in the crystal structure of a material reduces. Therefore, the hardness and ductility change. There are three main stages of an annealing process, which is recovery stage, recrystallization stage, and grain growth stage. During the recovery stage, a furnace or other type of heating device is used to raise the material to a temperature where its internal stresses are relieved. During recrystallization, the material is heated above its recrystallization temperature, but below its melting temperature. This causes new grains without pre-existing stresses to form. During the grain growth, the new grains fully develop. This growth is controlled by allowing the material to cool at a specified rate.
Quenching process. Quenching involves the rapid cooling of a metal to adjust the mechanical properties of its original state. In this experiment, steel is raised to a temperature above its recrystallization temperature and rapidly cooled. The rapid quenching changes the crystal structure of the steel compared with the slow cooling. Depending on the carbon content and alloying elements of the steel, it can get left with a harder, more brittle microstructure. It results in increased strength and hardness for the steel. Tempering process. Tempering steel after a hardening process allows for a middle ground of hardness and strength. This is achieved by allowing the carbon diffusion to occur within the steel microstructure. When steel is hardened, it can become excessively brittle and hard. Tempering also improves the machinability and formability of a hardened steel and can reduce the risk of steel cracking or failing due to internal stresses.
That's all for our video today. Hopefully you find this is interesting and get something from our video.